Okay, class, so for today, we'll be learning about functions and determining whether or not a set of ordered pairs, table, mapping, and we'll do graphs later, determine whether or not they're a function. And you're probably thinking, well, what is a function? A function, and make sure you get this down, function, x values do not repeat. X's don't repeat. Our x values don't repeat. And so another thing we can say is for every 1x, we have 1y. So for every 1x, we have 1y. And make sure you get these three down, our set of ordered pairs, the table, and mapping. And we're going to look at this set of ordered pairs. If we look at our x values, we have a 1, a 3, a 5, and a 6. And you'll notice that none of those repeat. And so off to the side, put a check and put function. X's don't repeat. So yes, this set of ordered pairs is a function because the x's do not repeat. And now let's look at this table. Here we look at the x values. We have 1, 2, 3, and 2. And so we will see there's two 2's in our x value. And we'll notice there's two different y values. And so x's don't repeat, so this can't be a function. So we'll put a big X, not a function. X's repeat. And then we'll look at the third one. We have a mapping. Our x values are 1, 2, and 3. Here it doesn't look like they repeat, but since the 1 has two arrows that come from it, the 1 goes to the 4 and the 5. And so up here it says, for it to be a function, for every 1x, we have 1y. Well, in this case, that's not true because for this 1x, we have two y values. So over here, we want to put a big X, and I would circle the 1, the 4, and the 5, just so you know why. So we'll say, put an X, not a function, because for every 1x, we didn't have 1y. And so I'll leave this video up just for a second so you can get this down. A function, x's don't repeat. Every 1x we have, we should have 1y. If we look at a set of ordered pairs, we're going to look to see if the x's repeat. In this case, they didn't. And then the table, same thing with the ordered pairs, see if the x's repeat. And then from the mapping, we're going to see if there's two arrows coming from that 1x. So now that we've looked at a table, a graph, and a mapping, now the next one will be a graph. And the graph's a little bit different in that we will be looking to see if the x's repeat, but it's going to be in a little different way. And the way we'll do that is the vertical line test. And make sure you're getting this down because this is very important. The vertical line test, what that means is any vertical line on a graph can only pass through one point. For it to be a function. So in the vertical line test, our vertical line anywhere on our graph can only pass through one point for it to be a function. And so I have two different graphs here. I have the one with the red dots and one with the purple dots. And so we'll look at the red dots first. We do this little dotted line. And so far we passed through just one point. And then we'll come over to the next set of part points, do our vertical line. And we pass through two different points with one vertical line. So on this left-hand side with our red points, this part would be not a function because we crossed 2 points with just one vertical line. Let's look at the right-hand side with the purple dots. So we draw a vertical line. We pass through 1 point, which is fine. Draw another one. Still just 1 point. And we just keep going. 1 point. 1 point. 1 point. So on the right-hand side, it's fine because we only pass through 1 point with each vertical line. And so vertical line test, any vertical line on the graph can only pass through 1 point for it to be a function. If it passes through 2 or more, then we don't have a function. Our x's repeat. And we get different y values. So here are your 3 practice problems for tonight. You'll determine if this table represents a function or not. And then the same thing with this set of ordered pairs. And then for number 3, I want you to give me your best explanation of why we use the vertical line test to determine if a graph is a function or not. And so I'll give you all a few seconds to write this down, determine whether or not the first 2 are functions or not, and explain why. And then number 3, just give me your best explanation of why we use the vertical line test to determine if a graph is a function or not. And don't worry about if you can't get it. I just want to see what y'all come up with, and I'll let y'all write that down.